Now, one of the reasons why Turing's proposal was so interesting and important was that it raised a certain tantalizing possibility to people working in the field of artificial intelligence. It was readily apparent that in order to pass the Turing test, all a thing has to do is be able to compute a certain function. Let me explain what that means. A function is an operation that takes inputs and gives outputs. Given the same input, it will always give the same output. Now, in order for a machine to pass the Turing test, all it has to do is, when given questions, like the questions I gave Damien in that conversation about feeling watched, the machine has to give the right answers, give plausibly human answers. So all we have to do is design a machine that, when given sequences of conversation ending in a question, when it's given that as inputs, all it has to do is give a plausibly human response as an output. And then if it regularly does that, given a sequence of questions as input, gives a plausibly human response as output, right, then the machine will pass the Turing test. And what Turing had also shown independently in different work, which is itself fascinating and very important, is he'd shown that complex functions, very complicated functions, could be computed by very simple machines running the right program, given enough memory, given enough time. Indeed, he showed that for any function that could be computed by almost any imaginable machine, there was a very simple machine that could also compute that function, so long as it was given the right program, enough memory, and enough time. So all these things together meant that what Turing had suggested was that a simple computer could think, because a simple computer running the right program could compute the function such that if you compute a function of that kind, then you'll pass the Turing test, and that, according to Turing is tantamount to thinking. So that set people off programming computers in an effort to pass the Turing test, and that led to interesting conversation bots like Eliza. Okay, but the question we have to ask ourselves is whether Turing was right, whether the strong version of the thesis that says that anything that passes the Turing test is a thinker, whether that's correct. And the worry that came up was that that doesn't seem to be right. It seems to be amenable to a certain kind of counterexample. So there seem to be examples of individuals that can pass the Turing test that don't seem to us to be thinkers. And a very vivid example of this kind was provided by a philosopher named Ned Block. And he called this individual Blockhead. So let's imagine Blockhead. Blockhead he's got a very blocky head, and but yet provides marvelous answers to questions. And we test Blockhead many times, and we see that he passes the Turing test. And we have conversations with Blockhead, very like that conversation I had with Damien about the people watching me. And so it seems to us, yes, according to Turing, Blockhead should be a thinker. But then we discover what's going on inside Blockhead's blocky head. And we discover just how Blockhead is generating the answers. And it turns out that it works like this. For every conversation less than a Google lines long, Blockhead has an entry in a vast list. So Blockhead has a list inside his blocky head of all conversations less than a Google lines long. It's numbered. There are a lot of them. I mean, just a tremendous number of them. And next to each entry in that list, Blockhead has a sentence in English. The sentence corresponding to the answer you give if the conversation has gone this way up to this point. And so what Blockhead does is he takes as input everything that's been said in the conversation up to now, and then looks it up. Where can he find that input in his list? He finds the input, he finds the appropriate place in the list, and then he looks at what the response next to that input is. And then he gives that response as output. So he just trawls through his list, and he finds the place you're in the conversation, the place we're at the conversation up to now, and then he looks across to what the appropriate response is at this point, and then he gives that as a response. That's the way that Blockhead answers questions. That's the way that he talks. Is Blockhead thinking? Well, surely not. Look, this conversation that we had, it had to do with, that I had with Blockhead, it had to do with, remember, with hands in ice water. Was Blockhead thinking about iced water? No, of course not. Blockhead didn't have any ideas at all about iced water. All that Blockhead did was, when the conversation came to the bit about iced water, Blockhead trundled through the list in his head, found a string of sentences that corresponded to the appropriate point of the conversation, and looked across to see what the response should be. That doesn't amount to thinking about iced water, clearly. What does amount to thinking about iced water? Well, that's a very difficult question, and that's kind of the question that's still left open here. We can at least point to something like a response, which is that, look, thinking about iced water, thinking at all, involves some kind of manipulation of ideas in your head. Why Blockhead is failing to think is that he's not manipulating ideas in his head. There's none of the right flexibility there that comes with thought. There's just a brute process that doesn't involve any kind of symbol manipulation, idea manipulation. And that's that idea of manipulation, that's what's characteristic of thinkers. Okay, so maybe Blockhead is failing in this way. Of course, you could say there still is a sense in which, by interacting with Blockhead, I am interacting with a thinker. Although the thinker isn't Blockhead. The thinker is whoever created Blockhead's list. After all, if you think about actually making a list of this kind, to make it up, you'd have to write down all possible strings of sentences, strings of conversation strings, a Google lines or less, and then write down for every one of them a response that was plausibly a human response to this point in the conversation. And that would require a lot of thought, a lot of careful thinking, as well as a lot of time. And so maybe the person who did that was thinking, and so my sense that I'm interacting with a thinker here comes with my interacting with the person who created the list. But of course that doesn't need to be the case. So suppose that Blockhead wasn't actually created by any human being at all. Suppose that there's some kind of natural process out there which just spits out blockheads. And it spits out blockheads in the sense that it splits out a blockhead-like machine, and then for every possible list that a blockhead-like machine could be operating upon, it spits out a blockhead like that. So there are vast numbers of blockheads out there in the universe, most of which are speaking gibberish, and you can't have any kind of conversation with them at all. You say, "Hi, Blockhead," and they go, blah, 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 blah. Because, again, they're just like Blockhead. They're looking for a response they're looking down their list. They're looking at the entry in the list that corresponds to the conversation up to now, and they're looking for the appropriate response given to that entry. And the appropriate response is just random. And so it's blah, 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 blah. But a very small number of them, of these blockheads, happen to have lists that give always plausibly human responses to the conversation up to now. And it just so happens that the blockhead I interacted with just now was a blockhead from this subcategory, a blockhead that would pass the Turing test. Here, no human being, no thinker was involved in the creation of the list that the blockhead used, and Blockhead himself wasn't thinking, so I wasn't interacting with the thinker. What should we conclude from this? Well, the thing to conclude from this is that if you want to make a machine, in particular a computer, that will be a thinker, then it's not enough to make a computer that passes the Turing test in virtue of computing a function that takes as inputs strings of conversation and gives as outputs responses that would be appropriate for a normal human being to that point in the conversation. It's not enough to do that because Blockhead does all that and Blockhead isn't a thinker. What more do you need to do? Well, something you might think is what you need to do is give the computer the right kind of program. It needs to compute the right kind of function in virtue of running the right kind of program. Blockhead is running the wrong kind of program. So we need to find the right one. And if you run the right program, and as a result of that compute the right function, and as a result of that pass the Turing test, then you're a thinker. So this is a weaker proposal than Turing's proposal. And it's all well and good. There are a couple of things that need to be filled in, and at least one purported problem with it. The thing that needs to be filled in is just what the right program is. What's Blockhead's program isn't good enough? What kind of program is good enough? And the remaining problem came in the reading that you saw for this week, which was John Searle. So Searle argues that even this weaker proposal is wrong, that for any program that computes a function that takes as input strings of conversation and gives as output what a human being would plausibly say at this point in the conversation, and for any program that computes that function, he can imagine a machine or a system that computes the function by way of running that program, but that isn't a thinker. And his argument goes, by way of counterexample, a little bit like the Blockhead counterexample. So we'll get to that in the remainder of the lecture.